This mini lecture is Evolution Redux, bringing back evolution, and we'll be focusing on interpretations of evolution, especially after Darwin. And I'd ask you to refer to the notes that are on Canvas as I talk about this. So there's different ways, two different basic ways, to interpret evolution. One is that it's totally random, that it's just the throw of the dice. All possibilities, all theoretical possibilities are equally likely. Randomness, by the way, literally means to wander aimlessly. Now, those who pick this side of the two ways to go in interpreting natural selection tend to be materialists. When it comes to metaphysics, that is the ultimate nature of reality, they tend to be those who say there's only matter and energy, nothing else. There's no purpose. It's all meaningless, at least from any larger perspective. So they typically are atheists. They tend to be radical in their politics, but not usually in terms of kind of just letting dog eat dog, social Darwinism. We'll talk more about that when we talk about competition in a few minutes. They tend to be more radical in the sense, maybe more akin to Marx and communism, that those who are most populous, have the most number of people, should kind of take control over those who, there's no established social order that's set up on purpose by some divine or some fate that is authoritative. No, it's all chance, and so those who have the greatest number should control it for the greatest number of people. Okay, so, and this side does tend to emphasize natural selection as competitive. It's all about nature selecting those who will reproduce and survive, and it's a matter of competition and survival of the fittest. Now the other side, and the later Darwin, by the way, tended to be this way, that there's, he became agnostic, so he didn't really see any guarantee of any kind of direction or positive movement in evolution. At least there wasn't any, it wasn't built into the system. There wasn't any likelihood or guarantee of that. All right, so then the other side is that there is some directionality. There is some progressivity. There is even some purpose, that a divine being or force at least has some purpose or tends in a certain direction, maybe greater complexity, more complex, more intelligent forms of life. Now, in his own way, the earliest Darwin actually did believe that there was some directionality, but kind of through the back door. He believed that survival of the fittest, just mainly competition, would lead to the most complex, the most intelligent creatures, and ultimately led to us. So in general, on this side of directionality, there are dice, but they're weighted dice to move towards greater complexity in life. Now, metaphysically, those on this side tended to be theists, believers in theistic evolution, that God, in some way or other, is ultimately behind evolution, that God has planned evolution, and here we're just talking about natural processes, but God has planned natural selection to lead towards more complex, richer forms of life. Politically, those on this side tended to be in favor of democracy, bringing everybody into the democratic process. First of all, bringing in men who did not own a lot of property, but any man, and of course eventually leading to suffrage, women voting, and so on. So they were progressive and reform-minded, not radical like maybe some of the ones who said it's all totally random on that other side of the spectrum of interpreting Darwin. Now, these folks tended to emphasize cooperation rather than competition, or cooperation as much as competition. Unlike the pure randomness, it's all, you know, competition. Dog eat dog. Only the fittest survive. And cooperation. Cooperation between species, as I'll scratch your back if you scratch mine. Like some birds, for example, will take insects or take burrs or spurs, burrs off the back of an animal, and the animal may provide some kind of shade or some protection from a predator for this bird, for example. But also cooperation within social species, like we human beings have learned to cooperate in a lot of ways and form great complex societies that involve a lot of cooperation as well as competition. Now, while we're talking about kind of the political and social, we do need to mention social Darwinism. But that the earlier folks who saw something more than just randomness tended to be more socially conscious, caring about everyone in human society, and then maybe beyond, caring about animals as well. But the social Darwinists took the sociality in another direction, and then they're back to just the competition, and they had no truck with cooperation. Those who survive are the fittest and the best, and they're the ones who get to reproduce and live the long lives, and we don't care about the rest. Now, there are other mechanisms in evolution, or proposed possible mechanisms in evolution besides just natural selection. That is, the environment selects for those who are best adapted, most fit to reproduce and live long enough to reproduce. And we've talked about these. Now, one is neo-Lamarckism, neo-Lamarckianism, which was really popular in the 1800s, kind of died out except in the Soviet Union in the 20th century. But this, you might remember, was the idea that traits that a species learned could be passed on to their offspring. And this, of course, with the arrival of genetics, basically Darwin believed in genes but had no idea, again, what genes might be, but we had Mendel and figured out the mathematics of genetics, and eventually the double helix with Watson Crick and their female associate. So that was one thing. But the related thing is the Baldwin effect, that now is generally accepted by even those who accept the so-called neo-Darwinian synthesis. And that is that species can learn more adaptive behaviors, and those behaviors are not passed on to their progeny, their children, but the intelligence that was able to learn and maybe learn from parents and these more adaptive traits can be selected for. So that's the Baldwin effect. I also mentioned previously, and I'll say a little bit more about how there is more mutations, greater mutations that go on when a species is greatly stressed by the environment, when things are really bad in the environment. Things have gone topsy-turvy. And so mutations are not just random. When the organism senses when it needs there to be more possibilities and to select something new that might work in this changed environment. And that leads to the next type of possible mechanism, and that's the self-organization of life. Now, we'll talk more about this when we talk about complexity and chaos theory, and that takes it back to the realm of chemistry and physics. And you already have self-organization within the mineral world, where certain minerals form crystals, become self-organized in a more complex form than just an ordinary rock. But life itself is a very complex form of self-organization. And species may themselves self-organize in a more complex form to meet new stressors in the environment. Not the organism itself, but the genes, the mutations, and so on, the genes that it passes on to its children. Its progeny might self-organize in light of particular stresses of an environment. So that's a possibility. So those are oh, and also one other thing that we talked about before, even in more ordinary environments, species do put stress, do put pressure on environments, on the greater environment. It isn't just the environment that works on species, but species also work on and shape and change their environments for their own benefit, like beavers building dams, birds' nests, rodents' burrows in the ground, and so on. And we human beings have put a whole lot of pressure on the environment, right, for our benefit, but also as our environment has become so polluted and global warming and so on, put a lot of stress on us and all species, unfortunately. So, but anyway, even in ordinary circumstances, species specify, select their environments. It's not just that nature selects species, but species select within nature their own environments. So those are some natural mechanisms that can make evolution a more directional thing that leads to greater complexity of life. There's also on the printout, off to the right with a sketchy arrow, processes that are not natural, that are beyond or outside the natural processes. One of those involves the so-called God of the gaps, that God might have, according to this theory, intervened at critical points in the evolutionary process. God generally let it go on, but God intervened at crucial points. One of those crucial points, for those who take this path, would be at that point where an ancestor to some apes and to humans broke off into the human line, and God intervened on this model to make sure there'd be humans. And of course, there are many humans that have become extinct. We're the only ones surviving now. There's also something we talked about before, which is intelligent design. The idea that some structures, even some biomolecules, biochemical molecules, are so complex that they couldn't have just evolved naturally. There had to be an intelligent designer that guaranteed that these would precisely evolve in that way. They couldn't have evolved from any previous form of life, any previous molecules. So this would be another form of intervention by God, but taking it down to the molecular level and claiming some scientific backing. Although the scholar, Michael Behe, who claims this, he's actually been disproven by other scientists who say, no, those molecules that you talk about, we can see, we have evidence that they have just naturally evolved. So, there's some more in-depth going over different interpretations, two basic lines of interpretation, totally random on one side, just emphasizing competition and randomness. On the other side, the dice are somewhat weighted. There's some directionality involved in evolution and natural selection and in other possible natural processes.